So, question that fundamental is that okay, for a derivative with this payoff, what should be the premium? And the premium we are going to denote by the phi. Okay. And this premium should be clear. In other words, it shouldn't be neither too low nor now imagine you spotted that because if something is priced low, actually, if something is priced low, okay, something is priced low, it's not well priced, then it can give rise to an arbitrage. Why we don't want arbitrage? We want to turn the market. So let me define something which is called extended arbitrage opportunity. Extended arbitrage opportunity. Simple. Imagine you kind of observed that okay, there is no trouble in the model, okay, but you observed that something has been mispriced, some derivative has been mispriced. So if it has been mispriced, then using that derivative by buying it or selling it, you should be able to create a portfolio which can kind of give us a guaranteed profit. So by extended portfolio, I mean X, Y, and Z. Okay. So the X is investment in bonds, Y is investment in the stock, and Z is the number of units of the derivative that you trade actually buy or sell. So that's an investment in derivative. Units of derivatives. Why you are calling derivative? It's not mathematical derivative. It means that derivative is something whose value is derived from some underlying thing, from some underlying asset.
So use of derivative means creatively many options.
Imagine that you thought you observed that okay, something is, so it's like some derivative is overpriced. Something is overpriced. What are you going to do? You're going to borrow it and you're going to immediately sell this. You're going to have lots of money in your pocket. If something is overpriced, okay, so this worth $1, but it's been sold in, say $2 now. So what are you going to do? You're going to sell it. And you're going to make immediately $2 money. Okay, you're going to put $1 in your pocket and you're going to invest $1 in bonds and in stock in such a way that in future, okay, if you are the person so when you are selling an option, for example, a derivative, you are in the short position. So in other words, at time 1, someone is going to claim, someone is going to exercise the option basically, the one who is in long position. Okay, he's going to exercise the option. Okay. So then what you have to do? So it's like you have to do this, that okay, you sold this in $2, you immediately create a portfolio which is going to meet with your obligations at time 1, and you are going to still remain with it. That's what you want. But if something is underpriced, you have to do the opposite price. Okay, you're going to get the long position. Anyways, so extended portfolio is X, Y, Z. Okay, so that's your investment in derivative, and we're going to denote it by a psi usually. Okay, and what should be the definition? Number 1. Okay, the value of psi at the point, at time 0 should be 0. So if it is an arbitrage opportunity, it should have the same thing. And the V1 of phi of omega is not negative. And there exists omega in omega such that V1 of psi of omega is positive. That's what the meaning of the extended arbitrage opportunity is. You are calling it extended because
Yes.
you are. And what we want actually, we don't want the existence of any extended arbitrage opportunity here to turn a market into a rational market. The question is, how to do it? The answer is correctly price the things. Okay. The question is, what should be the price of the derivative? The answer is law of one price. Okay. Okay, what I mean by the fair price for a derivative, a fair price is a price phi that prevents the existence of okay. Our objective is to just figure out this. Now, till the end of this course, we can basically see that there are two ways to compute the prices of derivative. Number one is to find a replicating portfolio. And the second is to find it through the risk neutral probabilities, risk neutral probabilities. This one is more efficient, but this is also important to learn. They are equivalent to risk neutral probabilities. I'm going to talk about it. So I'm going to tell you first quickly that how can I price things through replicating portfolio, and then quickly tell you that how can I price this neutral portfolio. Okay. Write a definition. What is the meaning of replicating portfolio? Obviously, replicating portfolio must be a portfolio in the first place. In other words, we are talking about something such that. But it should be able to replicate it. Replicate what? It should be able to replicate the payoff of the business. Okay. What does it mean? Replicated. Okay. So, a portfolio replicates portfolio phi replicates derivative if the value of the portfolio of phi on omega, you can attain the value of the derivative or the payoff of the derivative at time 1. Okay. At this time 1, so I'm putting 1 here. Okay. The payoff of the derivative in case of the scenario omega can be attained, can be computed, can be evaluated by the security. roughly. What I'm saying? I'm saying I have a derivative. For this derivative, can I find an investment in bonds and stock? Can I find an investment in bonds and stock which at time 1 gives me the value which is equal to the payoff? Okay. Just think about it. Why this is going to be a very interesting point. Imagine something is overpriced. So a derivative is overpriced. What are you going to do? You're going to sell it. You're going to keep the money. Okay, so you're going to be in short position. So what you're going to do? You're going to immediately create X and Y. Okay, you're going to invest in bonds and stock in such a way that at time 1 you can meet with your obligation, but you still remain with some money in your pocket. So you can meet with the obligation. Okay, so it's like if a guy is exercising his option, give it to him. Okay, here it is. Okay, but that but still you're going to have some money in your pocket because something is overpriced. And we're going to do some concrete examples.
Sir, this portfolio is extended one or?
No, it's not. Whenever I'm using phi, I mean, and I'll use psi for the extended. Okay. So what I'm saying, a portfolio is replicates a derivative. So it's a replicating portfolio for the derivative. Or the derivative can be attained. Sometimes you also use this terminology that derivative can be attained by this portfolio phi if its value at time 1 agrees with the base. Now, why this portfolio is going to be an extinct conflict? Miracle of this portfolio. Miracle is what you call law of one price. Law of one price. Did you already observe that how much this finance is getting sophisticated in terms of mathematics? It's getting bigger. Last time I taught this course, okay, the finance people were asking that, okay, so like I got this MS math and MS finance people together. So the finance people were saying that, okay, where is finance? We are just doing mathematics. And the math people were doing that, okay, finance. Where is mathematics with me? You are just doing finance. So they were having hard time in understanding finance, and the finance people were having hard time in understanding. Anyway, so it's not difficult. So what's law of one, correct? So it's a little theorem. Okay. This says that if phi, which is xy, replicates a derivative b. In other words, their values agree on at time 1. Okay, write that there must be for all omega, not just the one case, but in all cases. Okay. Okay. So if phi is a portfolio which replicates the derivative d, okay, then fair price of d derivative, okay, at time 0 is pi equal to, give me a guess. So if their values are agreeing on time 1, their values must agree on 0. Can you see this? What we are saying? I'm saying I have a portfolio. Imagine I can find a portfolio. You need to keep one thing in mind. This E of omega is going to be roughly known to us because we know the potential, what are the stocks actually. What potentially places. So this is something which is known to me actually in the beginning. Okay. So if I know that the value of this payoff is agreeing with the value of the portfolio, then this portfolio replicates the payoff. Okay. So if their values are agreeing at time 1, their values should agree at time 0, and that's what the law of one price is. If two things have same value at time 1, they should have same value in the future and afterwards as well. The moment they have a different price, we're going to have arbitrage. We're going to have arbitrage. Now just think about it. Why this theorem allows you to calculate the fair price of any derivative in one. Just think about it. So this is known to be. So I'll put U here and U here. Here X and Y is not known to be. I know that what is the replicating portion. So D of U is going to be what? X B1U plus Y B1U. And y S1U. And D is going to be what? X B1 plus Y S1D. So everything is known. So I know B0, I know D, I know S1. So I got a system of equation. Just solve it. You're going to get XY. And once you have that XY, I can immediately calculate this value at time 0. What's the difficulty? And whatever the value of this portfolio is going to be, and that's what we okay.
What's the
Getting it
Groups to the Get a student point.
I'll just put this giving them quick sketch. Give them this
Baba, your favorite possible definition is by the end of course cover thing. Reading your course.
So it's something simple. If time you're gonna read it, so you can do it quickly. Now I want that these two numbers should be equal. Okay? So suppose country that this doesn't happen, then what can happen?
Yeah, this is
In other words, you can have a case when pi is smaller than if this is the case, I'm saying that then I can construct arbitrage opportunity. And I can construct arbitrage opportunity. And that arbitrage opportunity is going to be an extended arbitrage opportunity. Okay. So I'm going to do this. You can do this. So this guy is cheap and this guy has more value. So what are you going to do with the cheap thing then? You're going to buy the cheap. And do the opposite is basically the portfolio. So I have portfolio XY already with me. So I'm going to do what? I'm going to create a new portfolio psi in which I am not going to make any change in the stock. The investment stock is going to stay same. Okay. Investment in the stock is going to stay same. And I'm owning one derivative. So I have a long position in one derivative. Okay. and I'm going to change my investments in X prime. So what should be my X prime? So it should be the previous bonds that you have, okay, and plus something that you have bought from this, something that you have from this difference item. So what is going to be this difference? This difference is going to be V naught phi minus phi. Okay? And I want to invest this into the bonds. So how many bonds I can buy from this amount? So the bonds say, for example, about $2. And this is divided up. If you are changing your investments in check, that's an extended standard. So it's going to have a zero. Formal scenario is going to test. Okay. For V naught phi less than phi, the derivative is overpriced. You will immediately create a portfolio. You already have a portfolio, it's phi. So you're going to do what? So you're going to just make a change in X prime. So in this case, psi is going to be X prime, Y, and negative 1. Okay? And X prime is going to be, in this case, your previous investment in bonds plus the difference that you have. Just think about it. These two things and these two things are the things that you have at time 0. So it's like when you perform these two things, okay, when you trade these two things, what's going to happen? You're going to immediately have the difference in your pocket actually. Okay? So I need to take the difference and invest in bonds. Okay? That's what's in our opportunity. So, if this is the case, then there is no other place for pi to live other than. Okay? You're almost done. You right? So we just got basically what you call a way to price the derivative. Okay? And if I want to really price the derivative, what I need to do? So imagine this is given to me. This is given to me. What this is payoff of some derivative. Okay? So what I'm going to do, I'm going to compute xy such that d1 of xy is same as d of omega. Okay. Now this is going to give me a system of equation. X d1 plus y s1 of u d of u is y b1 plus
What's the one?
x d1 plus y s1 of e equal to d of d. Okay, all these, I know b1, I know s1, I know d. Why I know d? Because d is a function of s. So it's like a function is given to me. So if s is known to me, d is given to me. So it's just a simple set of equation. And the answer is that does this system of equation have a solution or not? If it is, you can find a replicating portfolio. If no, you can't find it. So we can compute xy from here. And once you computed xy from here, the law of one price tells you that okay, the pi is going to be this V naught phi, which is that's 2 naught. Easy peasy. Okay. So that's one way to try it. I'm not doing examples, something elementary to use it. Okay. Let's come to the next approach to, which is called the risk neutral pricing, risk neutral probabilities. Okay. Now I want to test that how much of topology and analysis you have learned. So I have, my model is viable if this happens actually. Agree? So this is this kind of a situation that, imagine I have a number, this number which belongs to this interval. In other words, I have a situation, I have a number C which belongs to an interval A to B. So what properties do we know about the interval A to B? What logical properties do we know about? And bounded, okay. Okay, it's a convex set. It's a convex set. Remember convex set? So,
Straight.
so I can write it like that. So, so if A comma B is convex, in other words, if I take, for example, x from this interval A to B, and then t between 0 to 1, okay, and I make a convex combination of x, in other words, Tx plus 1 minus Tx.
Right.
This is also going to be what? See? That's one of them. And there is another thing. I can write it in another way. So I can say that A comma B is collection of those points for which there exists a T such that C can be written as AT plus 1 minus T. Because every element can be written as a convex combination of A. It should say X here. It should say X and I. Obviously, X and Y can be equal. Okay? So if C is in this interval, then I can find a T which is between 0 and 1 such that C can be written as the real function. Imagine A and B and C lies in the middle. Give me the T for that. Give me the T for this. Come on, you don't need to think that much. So it's going to be 1/2 actually. Because C is what? It's A plus B by 2. So it's going to be 1/2 A plus 1/2 B. But C could be here. What we are saying that C could be here. Okay? So I can basically, if this is a convex set, which is a convex set, what I can do that by creating such a combo with some T, I can reach to this point. Happy with this? This is the case. What immediately follows from here?
That's one of these numbers.
So we're gonna say there exists a Q between 0 and 1. I have two kinds of probabilities with me. One probability is which I am representing by P small p. we're gonna call those probabilities as, so it's like I have one probability like this, which is P and 1 minus P. Okay. Now, it can happen that there is, and that there can and there cannot be arbitrage in such models. Okay. These probabilities